Okay, so now we're going to talk about how to measure heat quantitatively. Okay, we're going to use the equation Q is equal to mc delta T. Q is the heat of something, m is the mass, C is called the specific heat capacity, and delta T is T final minus T initial. Again, the M stands for mass, and the Q is heat itself, so the thermal energy. Okay, so in this problem it asks how much energy, so I'm looking for a Q, how much energy in calories is required to heat an iron nail with a mass of 7 grams from 25 degrees Celsius to 750. So let's list the variables. Q is what I'm looking for, so I don't know Q. M is 7.0 grams. C is equal to, I'd have to come over here to a table and look that C for iron is 0.45 joules per gram degree Celsius. So 0.45 joules per gram degree Celsius. My delta T is going to be my T final. In this case, it's the 750. So I have 750 minus 25. So that's 725 degrees Celsius. Now that I have all my variables, I'm ready to use my equation. So you can see in this next slide, I've put in my 7 grams for my mass. That's right here. I've put in my heat capacity from the chart. That's right there. And I've put in my delta T right there. So I've gone ahead and calculated this out to 224 joules. You can also divide that by 1,000 and report the number in kilojoules. It doesn't matter. We can look at how many calories that would be with this simple analysis, dimensional analysis here. We're going to take 2,284 joules and we're going to divide that number by the amount of joules per calorie. So that's just a conversion factor. So in the end we get 545.9 calories. But that's not where we end the problem exactly. So we want to go back up here and we want to look at the number of sig figs that we should have in this problem. So if we look here, this number has 2 sig figs, and this number is from a chart, so we didn't measure that. Probably measured this, so this number has 3 sig figs. So my answer here should only have, this has 3 and this has 2. My answer's got to have 2. So I'm going to go ahead and round this number to 550 calories. And that's going to be my final answer. I'll put a big box around it. Okay, let's go on to do one more problem. This problem says what mass of water, so I'm looking for a mass of water, was heated if 2,320 kilojoules raised the temp of the water from 3 to 35. So again, let's list out our variables in our equation. Q, we know that this amount of energy was added, so joules, so that's going to be 2,320 kilojoules. That was our Q. We also know our delta T, so our delta T is the water was heated from 3 to 35, so T final, 35, minus T initial, 3, would give me 32.0 degrees Celsius. Alright, we want our M, so that's what we're searching for, so we don't know that. In terms of C, we can go over here to water, and we'll look at liquid water, so that's 4.184 joules per gram degree Celsius. Alright, so on the next page we'll continue this problem by putting those variables into our equation and solving. Okay, so here we go. We're going to start out by just looking at our units. Remember, our units for the specific heat capacity are in joules per gram degrees Celsius. We can't really change that. So I know that we were given originally this number as 2,320 kilojoules. But kilojoules here is not going to cross out with joules here. So what we did in this first step is we changed this number to joules. So that's important. So now that's in joules. The M, the mass, that's going to be right here. We just left it as X because we don't know it. The C we got from the table. Again, that's that number there. And the delta T is the 35 minus 3, which we calculated before to be 32. We're going to divide the number of joules here by the specific heat capacity of water and by that 32 degrees, and we should get 17,328 grams. The final thing we're going to want to do is adjust our numbers for having the proper sig figs. So our number we're going to reduce to having 3 sig figs, so this becomes 17,300 grams, or you can put that in scientific notation as 1.73 times 10 to the 4th grams. Okay, I'd like you to try to do these two problems for homework. Please write the whole problem down, pick out your variables like we did, and put them into the Q equals MC delta T equation. Good luck.